Hello, this video is a basic tutorial on how to use the new occultation timing extraction program PYOTE. The first thing you'll need to do is go and get the program. You can get it from either the North American Asteroidal Occultation Program webpage or the worldwide page. Just go down to where the software is located. In this case it's on the left hand side of the North American page, and click on the guide that you need for your computer, either Windows or Mac. Follow the installation guide carefully. There are downloads that need to be done, and when you're done you'll have the program installed on your computer. There will be a desktop icon that you can double click to start the program, and when you do that you'll be presented with this large black screen. The program is going through and making sure all the files it needs are uploaded, and if not, it will get them. It's automatic. We'll check for updates. This sometimes takes quite a while to occur, especially the first time you run through the program, and maybe if you don't run it for a few days. So be patient. Eventually, however, you'll be presented with the program screen. You'll get a message about the fact that this is the most recent version of PYOTE. If you need to update the version, the program will tell you how to do that. It's pretty easy to do. A couple of things to notice. There's an area for the graph. The program assumes that you've created a CSV file from either LiMovie or Tangra. If you place a cursor over some of the buttons, you'll notice that these pop up comments. So if you have a problem and you need a little help, you can just use those. But I'm going to skip those for now. All right, so here we go. Let's load in a light curve. We'll get a CSV file. I'm going to use a recent event from Cava that I've worked with before. When you load the file in, you'll notice there are two light curves that show up, one for the target, pretty obvious in blue, and one for a secondary star in green. Sometimes the secondary star is useful if we need to do some normalizing because of clouds in the background, that type of thing. But in this case we don't need that. Looks like it's a pretty smooth light curve, so we're going to remove that from our graph. Click that box. So there's our target star. Pretty obvious occultation. Now I happen to know that this is a 4-frame integration. You need to tell the program that there's integration going on. You can't really analyze and get accurate times on a video if it's been integrated, because the event could have occurred anywhere within that integration interval, and we don't know if it occurred at the middle, at the beginning, at the end, but the program is able to do sub-frame timing and extract that information pretty accurately. So the first thing we're going to do is to show the program how it was integrated. Notice my cursor is up near the title here at the top. It disappears when I pull down in the graph, but if you hold the Shift key down, you can keep it visible all the time. So I'm going to highlight an area down here in the event. It's best to do this in the event in case there's some timing issues. You'll minimize those by using data from the event. And notice now when I magnify it, I can see these groups of 4 data points. These are my 4 frame integration points. So I'm going to click on the first one of a set here and the last one of a set, and go over here and tell it to block integrate. And we're done. Now that step would not be necessary if there is no integration going on. You would skip that altogether and just go right to the analysis, which is the next step. Now for this next step we need to tell the program approximately where the D and the R events occurred. It's pretty obvious where this one is, so I'm going to mark the point at the beginning before the event and a point after the disappearance and tell it that's the D region. Notice it forms a nice green box. If the event's not quite so obvious, you can make these really wide. Let's just pretend I don't know exactly where this is. I'm going to make a wide one here. So somewhere in that area is the R event. Okay. So it marked it off like that. All it's going to do is it's going to take a little bit longer for the program to figure out where it happened, but watch, it doesn't take very long. It's done. Right, so it found our event, very nice square wave. Provide information down here that is just extra information if you'd like to see what's going on. We don't really need it for our purposes here. But our next step is to calculate the error bars and get the exact times. This thing will create a final report for us. So I click there, get a progress bar. It's all done. We get a set of graphs showing the noise distribution. These graphs will be placed in the folder in which the CSV file is located, so you can use those later. And you have information down here in a log file, which is also printed to your folder. The most important information in here is at the very bottom, where it tells us it has created a summary report for the Excel file. This provides the information we need to fill in the Excel file with times. Reminds us that we did a block integration of 4, gives us a magnitude drop, signal to noise ratio, DNR times. Let's see what the report form looks like when we fill it in. Here's a report form. We're interested in this bottom portion. GPS time inserted. In this case, an IOTA VTI was used, so make sure you click that. This program only works with frame analysis and video, so that's obviously picked there. And the program is PYOTE. I know the camera was a Wattec 120N, so you'd fill in your camera in that particular cell there. And I know it was 4-frame integration, but we have to fill it in as fields, and so I'm going to select 8x in fields. All this information is important for the spreadsheet to calculate the corrections. The green cells should not be available to you. Those are the corrected time cells. Let the program, let the spreadsheet do that for you. All we need to do is fill in the times provided by PYOTE. So we have 5 hours, 48 minutes, 18.9101. Notice it creates a correction for us. Our time, 5 hours, 48, 40.8353. Notice again the correction is made and shown to us. Error bars, confidence level of 68%, 95%, which is one we want, and 99.7%. Place those in the appropriate boxes. Last step, put in the signal to noise ratio. You now have a complete picture of this event, time-wise, error bar-wise, signal to noise ratio. It's all ready to go. You just need to make sure the top of the form is filled out correctly. So there you have it, a program to quickly derive event times and confidence intervals from a CSV file created either using LiMovie or Tangra. Good luck with your observations. I hope you find this program useful. I think it's a really quick and easy way of getting accurate information. Thanks for watching.